Welcome to tonight's video. We'll continue with part 2, the infinite series of geometric and arithmetic, but mostly we concentrate on geometric. So the next question, where we left off, talking about the interval of convergence, the range of values for x, so that the following series is convergent, meaning you can find the sum. And if we notice, it is a geometric series because we're multiplying by the same term to go from term to term. So to find the ratio, we take the second term and divide it by the first. And we know that in an infinite geometric series, to find the sum, that the absolute value of the ratio has to be less than 1, meaning it has to be between -1 and 1. So we have to solve this inequality. So we multiply by 2 to get rid of the fraction. And then we can distribute. We could divide, but then we'd have to flip the inequality. And by distributing, we can avoid having to do that. Because then we can add 3. And then divide by 3. Sorry, I forgot to add the 3 over there. So it's between 1/3 and 5/3. So we say that x exists in interval notation between 1/3 and 5/3. All right, so for number 11, it's the same type of problem, except now the ratio is going to be second term divided by first, so -1/2 times 3 minus x squared. So this ratio has to be between -1 and 1. So when we multiply by 2, actually we're going to multiply by -2 to get rid of the fraction. The inequality will flip, so we get 2 is greater than, this cancels out, so 3 minus x squared, which is greater than -2. Now we notice that 3 minus x squared is always going to give us a positive value. So it's always going to be greater than -2. So we don't have to worry about that. That's always going to happen. What's not always going to happen is that 3 minus x squared is going to be less than 2 if I flip that around. So that's where you need to find the intervals. So when I FOIL this, I get x squared minus 6x plus 9 is less than 2. When I move the 2 over, I get x squared minus 6x plus 7 is less than 0. So it's a quadratic inequality. When it's a quadratic inequality, I first have to figure out what numbers make it equal to 0. So I have to solve this equation. So I do the quadratic formula because there are no factors of 7 that add to -6. So I go the opposite of -6, plus or minus -6 squared minus 4 times a times c, plus or minus the square root of 8, because 36 minus 28, over 2, because there's 2a. So then it's 6 plus or minus 2 rad 2 over 2. And then if I factor out a common factor of 2, I get 3 plus or minus rad 2. So those are what are called your critical numbers. So if you make the number line, 3 minus rad 2 is here, 3 plus rad 2 is there. So now if you choose numbers in each interval, so remember rad 2 is about 1.4. So if I choose a number less than 3 minus 1.4, so like 0, my goal is to see, is it positive or negative when I substitute 0 in? Well, 0 minus 0 plus 7 is positive. If I choose a number like 2, 2 squared is 4, minus 12 is negative 8, plus 7 is negative 1. So they're negative. And then if I choose a number like 6, that's bigger than 3 plus rad 2, 6 squared minus 6 times 6, so 36 minus 36 is 0, plus 7 is positive. Since it's less than 0, I want the negative values, which means it's going to be between 3 minus rad 2 and 3 plus rad 2. That's your interval. All right, number 12, it says find x such that this sum is equal to 2/3. So the ratio is negative 1/2, 3 minus x squared. And the first term is equal to 1. So remember, the sum is equal to the first term over 1 minus the ratio. So it's going to be 2/3 is equal to 1 over 1 minus negative 1/2 times 3 minus x squared. So notice this is a proportion, so I can cross multiply. So I get 2 times 1 plus 1/2. I'll just plus there. Make that a positive. 3 minus x squared equals 3. When you distribute the 2, you get 2 plus 3 minus x squared equals 3. Subtract 1. So I get 3 minus x squared equals, or sorry, subtract 2. 3 minus x squared equals 1. Now there's a couple different ways you could do this. You could FOIL this out and then factor it, or you could take the square root. If you take the square root of both sides, remember that's plus or minus, so you get the absolute value of 3 minus x equals plus or minus 1. So you get 3 minus x equals 1, 3 minus x equals negative 1. So negative x equals negative 2, x equals 2. Negative x equals negative 4, x equals 4. So those are your two answers of 2 or 4 for x. Find two infinite geometric series such that the sequences are not the same, but the sums are. So here's a shortcut way to do this. Pick a number you want to be the sum. So for example, say the sum is 4. And then pick a first term. So for a sub n, the first term is going to be, so a sub 1 is going to be, let me get a bigger eraser. So the first term is going to be 5. For b, the first term is going to be 3. I just made those up. So now we have to figure out what the ratio is. So if the sum is 4, 5 over 1 minus r. So when I cross multiply, I get 4 times 1 minus r equals 5. So 4 minus 4r equals 5 equals 1 equal to negative 1/4. And then for b, it would be 4 equals 3 over 1 minus r. So 4 times 1 minus r equals 3. Equals negative 1, r equals 1/4. So a sub n equals 5 times negative 1/4 to the n minus 1, and b sub n equals 3 times 1/4 to the n minus 1. And those are